Okay, so for more ray diagrams for concave mirrors for a different object location. In the previous video you saw that we drew a ray diagram for the object that was placed beyond C. Now we're going to try and draw the ray diagram if the object is placed between C and F. You can also try yourself to draw the ray diagrams if the object is placed right at C to check where the image will be formed. Right now we are going to place the object between F and C. So somewhere between F and C you have your object. Again, your first ray will go parallel to principal axis, reflect off of the mirror, come back out through the focus. So let's draw that first ray going towards the mirror. Indicate the direction. It reflects from the mirror through F. Draw your reflected ray, indicate the direction. Now you're ready to draw the second ray. The second ray will go towards the mirror through F and come back out parallel. So let's draw that ray now. To the mirror and then comes back out parallel to the principal axis. The reflected ray going away from the mirror. The point of intersection of the two reflected rays is where the image will be formed for the top of the object. So this is where the arrowhead will be formed. Connect the arrowhead image to the principal axis to get your image. Your object, this is your image. Now compare the image size that you got in this ray diagram with the image size that you got from the previous ray diagram in a previous video. There the object was placed beyond C. Now we move the object to be placed between C and F. Between C and F, you can see that as the object position was changed, the image characteristic has clearly changed. It is still inverted, but look at the size of the image. Compare it with the size of the object, you will see that it is bigger than the object, and so your image size is actually enlarged. Now write down the SALT characteristics for the image that is formed here. S A L T. S for size. The image is magnified, or you can say enlarged, or you can just say bigger. The size, image is magnified. Aptitude, you're specifying whether it's upright or inverted. Remember, images formed above the principal axis are upright. Images formed below the principal axis are inverted. So this one is an inverted image. Location of the image is beyond C. Anywhere on the left of C is known as beyond C. So that's what you say here. Beyond C. And the type, object and the image are on the same side of the mirror. So it's a real image. Okay, now we are going to draw a third ray diagram for concave mirror. This time we are now moving the object even closer so that it is now going to be placed between F and the vertex V over here. Okay, so I'm just going to change to a new page. I'll quickly draw my concave mirror. Use a ruler to draw the principal axis, passing through the vertex and the center of curvature. The principal axis, and since this is a concave mirror, I'm going to represent it using the dashed lines. So that's my center of curvature. Halfway between the center of curvature and the vertex is my focal point. Focal point F. And remember, this time our object position is between the focal point and vertex. So let's place the object over here. Okay, let's start drawing the ray diagram. The first one goes parallel to the principal axis, comes back out through the focus. Now this one is a special ray diagram. You need to pay closer attention to this. Okay, reflected ray comes back out through the focal point. The second ray was actually the one that passes through the focal point, hits the mirror, and comes back out parallel to the principal axis. But now you will see that there's no way you can place your ruler between the object top and the mirror so that it passes through the focal point, because now the focal point is on the left of the object. So here's what you need to do. You actually place your mirror so that the top of the object, the focal point, and one point on the mirror, all these three lie on the same straight line. So place your ruler so that the top of the object, the focal point, and the mirror lie on the same line. So this will be your ray going from the top of the object towards the mirror in line with the focus. Okay, so this becomes my incident ray. And remember that if the incident ray passes through the focal point, or even if it's in line with the focal point, it comes back out parallel to the principal axis. So this ray here comes back after reflection, goes parallel to the principal axis. Now this is something different from the ray diagrams that we've drawn before. Before, you saw that the two reflected rays actually intersect at some point on the left side of the mirror, but here you see that they're going in two different directions, and no matter how long you extend the two lines, they will not meet. This is when you know that you are going to be getting an image on the other side of the mirror, which would be then your virtual image. So how do you find out where this virtual image will be created? So here's what you do. As soon as you find your reflected rays diverging, meaning going in different directions, you will now extend these two reflected rays backwards. So I'm going to extend this blue ray backwards and the red ray backwards and find out where the extended rays meet. And usually when you extend a ray in optics, you represent the extended part with the dashed line. So this blue ray actually is going in this direction. I'm extending it in the opposite direction, and so I'm going to draw dashed lines over here on this side. Okay, and I'm going to do the same thing with the red reflected ray. I'm extending it so that it will meet the extended blue line. Extend it using dashed lines. Okay, so you see that the real rays do not meet after reflection, but their extensions do meet up at this point. So at this point is where the image of the top of the object will be formed. So your arrowhead is formed here. The image of the arrowhead. Sorry about that. I can also extend the principal axis on this side. And now, remember, once you locate the image of the top of the object, all you have to do is connect that point to the principal axis, and that's exactly what I'm going to do here. Okay, so this is the image of the object that was placed between F and V. Okay. Clearly, the image and the object are on two different sides of the mirror, making the image a virtual image, and also this image cannot be captured on a screen. Again, write down the characteristics of the image. Size, you can see it's definitely magnified. Aptitude, until now we've seen all inverted images. Here you see an upright image because it's an image that's formed on top of the principal axis. So you say aptitude, it's upright, meaning right side up. Location, it's nowhere on this side of the mirror, it's on the other side of the mirror. So that's exactly what you say. Other side of mirror, or you can also say behind the mirror. And type, since the object and the image are on two different sides of the mirror, type is virtual. It is not a real image, it is a virtual image. Okay, so this is the technique that you need to follow to draw the ray diagrams for concave mirrors. Now, bear with me for a few moments. I'm also going to show you one specific page of your textbook that has a table of the salt characteristics of the images formed in a concave mirror for different object positions. You can actually use this time to actually open up your online textbook. If you have saved it as a PDF, then open up the PDF. Okay, so I'm ready. I'm just going to move my camera to the computer screen. Let's show you the page number that I'm talking about. It is page 421 of your textbook that has a table of ray diagrams for different object positions in front of a concave mirror. So you will see here the object is placed beyond C, the image is formed between C and F. The object is moved between C and F, the image is formed beyond C. The third one there is the one that we just saw. The object is actually placed right no, this is the one that we just drew. The object is placed between the focal point and the vertex. You will see that an enlarged virtual image is formed. Now this is the one that I'm going to leave for you. Place the object right at F. Follow the same technique to see that if the object is actually placed at the focal point in front of the concave mirror, no image will be formed because the two reflected rays are are parallel to each other. So even if you extended them backwards, they will still not meet. So no image is formed at focal point. There's one more point, object location, that is not shown in the textbook. That object location is object placed right at the center of curvature. So go ahead, follow the same technique to draw the ray diagrams for object location at C and object location at F. Good luck.